Yep, so my name is Padraic Calpin. I work as a back-end engineer, and I have a strong interest in operations and infrastructure for Zensor. We're a Belgian company that develops a single-tenant software-as-a-service platform to provide monitoring and insights for civil and industrial infrastructure. And the talk I want to give today kind of comes out of the work that we did automating management of our platform in Python. So to begin, the reasonable question to start with is, what are we trying to automate here? And what I want to talk about today is pretty much anything that's happening outside of the actual application code itself. And to be a bit more specific, that's more or less everything that happens after you're pushing a code change up to your version control system. This is kind of the core idea of continuous integration and continuous deployment, that we want to treat every single small code change to quality assurance and even deploy it as well. And this is so much so that the term CI/CD has kind of become a shorthand in the industry for these very workflows that we're subjecting our code changes to. They're also called pipelines because they're made up of little individual steps like linting and testing, and we can imagine our code sort of flowing through the steps one at a time. You could take the metaphor even further and imagine your code being refined, if you like, as it flows through the pipeline. And typically, these are running off in some remote runtime somewhere, so they're not actually running on the developer machine itself. So CI/CD pipelines are a pretty critical part of modern software engineering, but they don't always have the best reputation. They can be seen as, complicated. They can be seen as flaky. They might fail unexpectedly. They can be slow. They just take time to execute. There's network requests involved, remote runners. Or they can be opaque as well. It can be sometimes hard to reason about what the pipeline itself is doing. And this comes from the fact that they're made up of a mix of, first of all, different individual, they can be one-off code chunks, shell scripts, tool invocations, and other incantations that are kind of thrown together one after the other, usually ad hoc for a given project. There's the fact that as well as the pipeline code, you have to configure where it's running, and that's usually using some kind of finicky config language like YAML. And then there's the fact that the runtime is a black box. It's something that's either very difficult or even impossible for us to access directly. It's pulling in proprietary code, it's pulling in third-party code plugins, and all of these things mean that in practice, the only way we can debug it is just by flinging another code change at it and seeing what happens. And what this kind of culminates in is a mentality that's called push and pray. It's kind of a learned helplessness where we treat the pipeline as like a fickle god, and all we can do is keep offering code changes and pray that we get some kind of green check mark back at the end of it. So what can we do to fix this? Well, this kind of suggests two different threads we could pull on. The first is to change the way that we write our pipelines. So instead of just gluing together individual bits as and when we need, we try to treat them holistically. So we look at them end to end. And we also maybe look at switching to something like a higher level scripting language rather than like combinations of shell scripts and things like that, which means we can also benefit from all the good engineering practice that our application code benefits from as well, testing, code reuse, developer tooling, etc. And then the second thing we want to do is decouple ourselves from the remote runtimes. So that has the obvious advantage that we can run the pipelines ourselves locally. It means that we could move to a different provider if we want to. But that also has some other advantages as well. We might get quicker feedback if we're able to run these pipelines ourselves on our own machines. And it also gives you redundancy, right? If GitHub Actions has an outage, you can still deploy your application because you can run the pipeline yourself. And this is actually, there are actually VC-funded companies that are pulling on exactly these kind of ideas, and probably the most prominent of those is Dagger, where they look at trying to solve this by using the same technology we use to deploy applications. So they are bundling, their idea is you bundle your pipeline steps into containers, and this gives you a degree of isolation from the underlying environment. And then they combine that with a really nice programmatic API that you can use to define those steps and then chain them together into a complete workflow. And some of the things I just mentioned, so code reuse, portability, these are like explicit goals in their marketing copy. This is the problem that they are trying to solve. But having said that, so this is not to speak ill of Dagger. We used it at Zensor for a long time. It's a really powerful tool. But there was a couple of things that we found in practice when we were using it. First is that you still needed to do quite a lot of scripting around the containers themselves. And most of this was about setting them up to make sure they were would run correctly. Things like injecting secrets, injecting environment variables, authorizing with cloud providers. All of this we still had to write code to do. And the second thing we found is that we're actually Python developers. So we were configuring our pipelines with Python, and then those containers were also installing Python and running the same version of Python we were just using to set them up. So rather than actually freeing us, the containers weren't acting as an abstraction, they were almost acting as an obfuscation of the environment. They were maybe like causing a little bit of friction rather than, which is not what we expected. So what we decided was to switch to pipelines that use just native Python and run almost identically, regardless of the runtime that we're targeting. And Python is obviously a pretty ideal candidate for this. So not only is it already a cross-platform language that's really capable for scripting as well as for applications, we can also benefit from the experience of the fantastic Python community. So we have a large number of existing libraries and solutions that we can use when we're writing our pipelines. The flip side of that is that managing those dependencies and managing a Python environment has also had a bad reputation for quite a long time. But actually, having said that, it's, I think nowadays, easier than ever to end up with a consistent Python environment on your system. And that's because of two kind of changes in the ecosystem that have pulled together in a very nice way. The first is the python-build-standalone project. So this is a community project, I think, currently managed by Astral, that produces statically linked, up-to-date builds of modern Python versions. And the nice thing about them being statically linked is that they're pretty easy to install on any operating system. Totally hypothetical, you could take if you had say you had a legacy Ubuntu 16 box somewhere, you could actually install Python 3.13 on it if you wanted to. And then the second thing is this, there's been quite a lot of development in project tooling around Python as well. In a talk at PyCon US this year about virtual environments, Zany Black from Astral used this term I quite like called workflow tooling. So this recent generation of tools like Hatch, Poetry, and UV, they take Python's existing capabilities for reproducible, isolated environments, and they abstract them away from the developers. So you don't have to care about if you've got a virtual end, if it's activated, where you're installing your dependencies. All of this thing is automatically handled for you. And it means it's, as I say, really easier than ever to end up with a consistent, reproducible environment on your system. And this means Python is a great candidate for writing pipelines. So we have kind of 3 rules of thumb that we developed at Zensor for creating pipelines in code. The first is that we try to keep our pipeline code completely isolated from the application. And we usually do that by just having an extra package in the repository root. We call it pipelines. You can call it what you want. And the actual pipelines themselves then are executed as modules inside that package. We use a package because it's, like I said, one of the goals is we want to treat our pipelines holistically. Keeping it as a package means they have consistent sets of dependencies, and we can also obviously leverage Python's import mechanism to allow code reuse, defining common constants and functions in our pipelines that both improve their maintainability, but also make it easy to add new automations as and when we need them. And I also advocate this. There have been, with the acceptance of PEP 723, Python does now have the ability to put dependency requirement specifiers in scripts as well. But I would still advocate for packages over scripts. Like I said, we want to have a consistent environment. We want to look at our pipelines holistically. If you're suddenly managing things on a script-by-script basis, again, you lose the code reuse, and you also can end up with inconsistencies, different versions of different libraries in different scripts. It just undoes what we're trying to do. The second thing we do is we then, like I mentioned, we want to benefit from all of this nice tooling, so we delegate the workflow management up to our workflow tools. Every single modern Python project tool has some command like run that will automatically set up your virtual environment and activate it and invoke your code. So that's exactly how we're going to run our pipelines. And then we usually couple this with a command runner, something like just or make, that makes it, even though these invocations are quite straightforward, they can still end up being quite a mouthful. So it's always very nice if you can just write just test and rather than the full line of code above. And the nice thing about a command runner is if you have multiple pipelines that just for sort of logic's sake you want to keep separate in code, your command runner can help you chain some of them together into, like, there are some steps you need to run in sequence, for example. And then the final rule of thumb seems like kind of an obvious one, which is that we try to keep as much of the logic as possible inside Python. And the reason for that is twofold. First of all, the more time we spend in Python, the less we have to think about the actual underlying system that our code is running on. But also, the more that we're doing natively in Python, the more we can leverage the developer tooling that we come to expect. And this comes in a few different ways. It can be simple things like making sure you're always using Python's built-in cross-platform functionality, so say like a high-level abstraction like pathlib instead of hard-coding things or using string operations. But it also means that you should look at native libraries and implementations, and you should always prefer those over calls out to the host. Take, for example, Git Python. It's a Python re-implementation of Git, and that might seem kind of strange, but actually, if you have to work with Git in a pipeline, it's fantastic. First of all, we don't have to worry about if Git is installed, what version is installed on the system. But it also means that the outcome of our commands is already a native Python object. We don't have to now go away and pass the output that subprocess spat back at us. We don't have to do any of that at all. And then the final thing I want to note here as well under this point is that if you're using Python tooling, you should try to leverage it maximally. So for example, if you're using PyTest as your test runner, PyTest has loads of built-in capabilities around controlling test execution. It's between fixtures, marks, and hooks. You can do quite a lot to control how your tests run. And you should be always trying to use that, so implementing that logic in Python code, rather than relying on specific sequences of commands running on the host to make sure you're selecting the right things and setting everything up correctly. Okay, so coming back to the 2 threads we want to pull on, we've already said we can try to change the way we engineer our pipelines, and we want to do that with Python. And the way I've talked about that has already kind of implied that we should get some sort of extra portability by doing this as well. But that's fine, okay, and that's pretty certainly helpful if you're running things on your own machine, but how can we also make sure that we're decoupled from the remote runtime? How can we take these pipelines that might run nicely locally and keep them also running up on our remote runner as well? So let's look, to answer that question, let's look at a pipeline in its simplest possible step form. It's just a sequence of steps that run one after another. And if we want to take that and make it robust, the simple thing is we can just branch. Whenever our pipeline hits some kind of case that has to be handled differently depending on where we're running, we use some kind of test, we handle it in code, and then we go right back to the common execution. This is kind of a contrived example. A slightly more realistic one might look something like this. So I've tried to annotate this. The labels I appreciate might not be very legible. So the first section is initialization, where we have some extra steps that are running only on the remote case. We then have the execution phase in the middle, where maybe there's some common pipeline code, and then at some point it has to branch. And then finally we have the teardown, where maybe we have to do some extra cleanup on our local machine, because unlike a remote environment, it doesn't get destroyed at the end of execution, so we need to make sure we clean up after ourselves. This might seem a little bit like cheating, like we're writing 2 sets of pipelines, and we're going to end up right back in the situation where our remote code cases are hard to debug. But the point is that we want to keep these branches as short as possible. They exist only for the cases where there's irreconcilable differences in our runtime environment, and the branch exists to reconcile that difference and then stop. By keeping them as short as possible, we minimize these divergences, we minimize the code surface we have to test, we minimize the risk of something going wrong, again, in a far-off environment that we don't have access to. And a final point as well, but something that bears repeating, is that the actual tests that you're using to do these branches should be as foolproof as possible. You can try to use something like looking for an environment variable or the presence of a particular file, rather than something that might fail for unrelated reasons, like, say, a network request. But then it bears the question, how do you figure out where your pipeline has to branch? And this is generally going to be, like I said, it's going to be a question of your runtime environments. And the question you have to ask yourself is, what can you assume about where your pipeline is going to be running? In the local case, this is actually something that you have complete control over. Depending on the size of your organization, it might come through your IT or security policies, or if you're an open source project, it can be laid down in your developer or your contribution guidelines. But when it comes to a remote runner, that's really going to be a function of whatever provider you happen to be using, whether that's GitHub Actions, GitLab CI, or something else entirely. And the rule of thumb that we developed at Zensor is that we basically want to think of our remote case just as a nice serverless runner that's really integrated with our VCS and triggers automatically when we want it to. And that in turn means that we're incredibly selective about what other features our CI/CD provider offers. So we really try very, very hard to avoid things like workflow plugins, things that might do whole common pipeline operations, or features like secret storage, features like conditional execution. We try to keep that to an absolute minimum. In fact, what we found in practice is that the best way to use a remote runner is that the beginning of the pipeline is that you can use some of these features, but you use them only to bring the remote runtime up to parity with the local case. So that means basically your pipelines, this is a kind of a toy example here in GitHub Actions YAML, but in the beginning you're going to have some kind of setup step that's just making sure the right tool versions and everything that you expect is present on the machine. And then it's just running the exact same commands as your local developers would use. So you're minimizing the amount of configuration you have to do, minimizing the number of ways that this could blow up in your face, basically. And what I want to do now, with the last kind of 10 minutes that I have, is walk you through an example of how you kind of specify these technical assumptions, and then how these assumptions bubble up into your pipeline design, and also hopefully it'll show some examples of how that is reflected in code as well. So let's take a toy pipeline, and we're going to just begin with a really high-level description. So this is a test pipeline that might just look like this. It installs dependencies, we run linting and type checking, and then we run our tests. So what you want to do is, the way I kind of approach this is we try to decompose these steps. And each time we kind of zoom in, we want to add a level of technical detail. So here, for example, I've made some specific tool choices. But what we also need to do is make a note for ourselves of what things these tools are going to require to run correctly. For example, okay, we want to use UV as our package manager, but where is it getting packages from? Are we using public PyPy? Does our security team have a private mirror? Or do we have some internal packages where we need to authenticate with some other secondary registry to pull some private packages? We're using Rough and MyPy. How are we configuring those? Are we expecting a global config to be present on the system, or is it in the Pi project TOML, for example? And okay, we want to run tests. Are we running all the tests, a subset of them? What do our tests need? Do they need secrets? Will they need some kind of additional service, like a database, to be running for integration testing? These are all the things you want to kind of think about. And at the end of this exercise, what you're going to end up with is a much more detailed pipeline that looks something like this. So in this instance, we've blown it up to add extra steps like authenticating for private libraries, and then we're splitting into unit tests, secrets. We maybe pull down some extra data that our integration tests need, and finally we run the integration tests. And alongside all of those, again, we just make a note. You have to kind of make a note for yourself of what this is going to need to run correctly. So, for example, we might need some test data for our databases. Maybe we are having to pull that down from S3, which means we're going to have to authenticate with AWS. If we want to select different set tests, we've got to make sure we're using marking in PyTest, for example. And the end of this exercise, what you're going to end up with is something that looks a bit like this. So this is a table where every row is one of your technical requirements, what your pipeline is going to need to run correctly. And we've shown how we're going to satisfy that in the local runtime and in the remote runtime. Yeah, and you can see here that if you look at the remote case, again, this is just to re-illustrate the point I made before, that we are using plugins, but we're using them solely to try and satisfy these technical assumptions, so to set up our remote environment, and once that setup is done, we're just using the same pipeline code that's running locally. And so with that, I think I have time to kind of go through a few examples from this pipeline. So let's look at the first case, which is authenticating with a private registry. So the Python package managers, UV and pip, both can be configured either through a configuration file that they know where to look for, or they'll try to pull that configuration from environment variables. So if we, as per our kind of technical assumptions here, we've said that we're going to expect our developers to have that kind of config file on their machine. And probably we want that because we want them to be able to run UV commands outside of scope, right? We don't want them, if they ever have to interact with packages, we don't want them to have to only do that through our pipeline. Probably they'll need to do that otherwise. And in the remote case, this is actually an instance where maybe it is a good idea to use a secret, to use one of these encrypted secrets. But as again, it only exists there as the setup. So here's like an example in GitHub Actions YAML where we're setting the right environment variables by pulling them from our repository secrets. And then when it comes to actually running this pipeline, we fall back on UV's default mechanisms for finding config. It will just run and do the right thing, and we don't have to think about it. As another example, we can look at cloud vendor authentication. This is kind of a similar case, conceptually similar to the other example, but slightly more complicated when it comes to like doing it remotely. So we're going to be using, probably, if we want to interact with AWS to do things like inject secrets into our pipeline, we'll be using Boto 3. And Boto 3 also has its built-in mechanisms for discovering configuration. So let's go back to our requirements table. We're going to say that our developers have single sign-on set up on their machine. Boto 3 already natively understands that. That's fine. In the remote case, maybe this is one instance where we'll have to use the vendor plugin. So AWS provides a plugin for GitHub Actions that will use OIDC to do the authentication dance, and then it will automatically inject some environment variables into your pipeline. And what that means concretely in code is, again, you don't have to care about it. Your pipeline just does import Boto 3 and runs, and we fall back on Boto 3's configuration discovery mechanisms, and everything works just fine. And this is the final example I'm going to do now. This is a slightly more complicated one. But I think it's nice because it shows how we can use a little bit of Python to reproduce features that you might expect are only offered in your remote runner. So most CI/CD runners give the ability to do conditional execution, so you can skip a certain pipeline step based on if files have been modified or not. And the way we can reproduce this in Python is we're going to make use of PyTest hooks and the GitPython library that I mentioned before. So this is a really simple, GitPython, like I mentioned, is a nice Python implementation of Git. And this code, basically, the first code snippet shown here, what it tries to do is it looks at the repository, figures out if we're in a pull request or just a change from master, which depends on if you're working locally or not, and computes the diff. So it returns you a list of all the files that have changed since the most recent commit or since master. We can then combine this with the PyTest hook. So PyTest has a hook that runs when it's figuring at the beginning of execution, when it's figuring out what tests are available and which ones it has to run. In that hook, we take our files, basically, and if none of the files we expect, if none of the files we're worried about has changed, then we can apply a mark to any tests that have a particular mark. We'll make sure to apply it, and that means PyTest will automatically skip their execution because the file hasn't changed. What do we need to do to make this run correctly? So locally, no extra config is needed. This should just run straight away. Remotely, you might have to make sure that your full history is checked out. So I hit this issue myself. GitHub Actions, by default, does a really thin checkout just of the most recent change of your commit. If you want this to work correctly, you'll have to make sure that you've pulled the full history. But once you've done that, you've reproduced this, like what previously was a runtime-only provider, in a completely agnostic and portable way. So I'm going to skip that. In conclusion, I hope that these examples are by no means definitive, but what I hope I've shown is how this practice of defining your runtime environment informs your pipeline design, and how it also helps you to design pipelines that can really safely handle running locally on your developer machine and remotely. As I mentioned, the remote-only steps almost always end up just in the config, just at this initial setup phase. And our local-only steps make heavy use of the technical assumptions we've made of the underlying environment, basically, how we expect our machines to be set up. And then altogether, I also hopefully, especially with that last example, have shown how you, by writing your pipelines in Python, you can leverage the full power of it as a scripting language to even reproduce more advanced pipeline functionality locally, completely portably. Thank you very much.
Thank you for the talk. Do we have any questions? If so, please come to the microphone. It's right there in the middle of the room. Thank you. This way, everybody, including remote folks, can hear the questions.
Thank you. Really cool idea to do everything in Python. One question is, a lot of people are super used to the nice UI visualizations pipelines bring with it, and here you don't get that, right? Do you have any ideas how to maybe recreate that as well?
Yeah, that's a very fair point. Probably the simplest way you can do that is by decomposing the pipeline steps. So there in the example, I had something like just test that was running a test pipeline that was going to do everything, linting everything, for example. maybe you want to you could decompose that. You could have multiple modules, and you could run them in individual steps in your config. It will make the config slightly longer, but it at least would bring you back some of that. You have some control as to how granular or how coarse you want to go, and that's also why I mentioned that one of the nice things of a command runner is if you want to keep your pipeline steps separate for logical reasons, then you can use your command runner to easily chain those together, or to give a better, say, developer experience. So maybe GitHub is using individual, very granular steps, but your local devs can run just test, and it does everything end to end, for example.
Thank you. Next question, please.
Thanks. I knew about Dagger. Is this repo? So I have two questions. Is this pipelines? Do you have any repo or package publicly to like a sample project?
So the question is if there's any kind of public examples of this approach. No, not at the moment. That is something I should do. So I have a package I've maintained. It's a sort of pretty stable, so I don't have to do a lot. I could add some example code there, especially because a lot of my own experience doing push and pray was when I first was learning how to do GitHub Actions on an open source project. So I could definitely upgrade that.
Okay. And the second one, how do you deal with testing? Can you test those pipelines with Python?
You could. It's not something I've done in practice. I've mostly tried to fall back on developer tooling to make sure things are running as expected. It's something you can do. It does add it would be an important practice. There was actually, I think, a nice talk at PyCon US on who tests the testers. But it's not, that's something you can do, certainly.
Thank you.
Hello, thank you for the talk. Can we go please back to slide 16?
Sure.
Yeah, so I don't have a question, more like a correction, because you said it actually 2 times that Git Python is a re-implementation of Git, and I'm pretty sure it isn't. It's just like more like a wrapper, and it's also not true that because it calls Git as a sub-process actually.
Really?
So
I wasn't.
Yeah.
I feel like I've looked at the source code of. Okay, I've looked at the source code of Git Python. If it does that, I've missed it myself. But okay.
Okay. Yeah.
Thank you very much. Can I have next question, please?
Thank you for your talk. Actually, in our company, we're planning something similar, and we were thinking also about pre-commit to as like command runner. Have you considered that as well? Because at least they also have the CI for things, which are, unfortunately it's not possible to install things there, but it looks very promising as a runner, and also like to maybe skip the pipeline folder at all.
Mm-hmm. So the question is around using pre-commit. So where I work, actually the principal people who are interacting with the coder are data scientists, and they sometimes prefer these things to get out the way when they're committing. They don't always necessarily want everything to run on pre-commit, but it's certainly good practice. That's something we can think about.
No, I mean really using pre-commit for both, for this pipeline itself and also for doing pre-commit, because you can define hooks to run manually, and then you can just say pre-commit run manually and then runs in the CI, or like runs the full test. So using pre-commit as your
Command runner.
Command runner.
Okay, yeah, I have to be very honest that I'm like aware of pre-commit conceptually. It's not something I've used personally on projects, but that does sound like a pretty cool approach actually that would give the same functionality. Yeah.
Thank you very much. We have one more person.
Yeah, thank you for the talk. You showed a lot of examples with GitHub Actions, which I think is a thing of its own. And what we use at my work is GitLab CI, which doesn't really have a concept of these setup steps, but instead it's like each job runs in its own Docker container, and which means that it's very hard to decouple the setup from the actual pipeline execution, because they all live in the same container or in the same multiple containers. Do you have any experience with this, or like tips how to manage this sort of CI provider?
I don't have direct experience with it. in a certain sense, that sounds like it would make things easier. You'd rather than delegating things to the YAML config, you'd be delegating it to Docker files. Probably, just off the top of my head, what I would probably have alongside the pipelines would be a directory of Docker files for the individual steps that are maybe also built at regular intervals. I don't know, something like that would be, to me, I think, a way to encapsulate that environment. But in a certain sense, that sounds almost easier because you have more control. You don't have to start with some base runtime and build it up. You have the container that should have everything you need already installed.
Thank you.
Thank you all. Thank you for the talk.
Thank you.